Review. We're going to do for our quiz 8 review. All right, let's see what we got. So question number 1 is f of x equals 3x squared plus 10x plus 3 over x squared minus x minus 6. Okay, so I want to factor. That's the first place I would start, is factor the top and the bottom. So the numerator factor and the denominator will factor, okay? Anytime we factor a trinomial with the number in front of the x squared, a leading coefficient, it gets a little bit trickier, but we're going to be smart and figure it out. Now, the only way I can make a 3x squared is really with a 3x and an x, right? That is how I'd make a 3x squared. Now, the multiples of 3, that's easy, 3 and 1. But we have to be careful where we put the 3 and the 1. I'm going to put the 3 over here and the 1 here because I know when I try and make this 10, and I call it the double smiley, there's my 9x and my 1x. If I need a positive 10, I would use a positive. So sure enough, I should get a 9x and a 1x makes my 10x, right? Now, let me put a 1 right here. Makes it easier. I'm going to go x and x for my x squared. Multiple 6, that's easy. 3 and 2. I need a negative 3 and a positive 2 because that'll make my negative 1. I need a negative 3 and a positive 2. Interesting. Why don't you guys make this a plus? Change the problem, make that a plus. I thought I'd fix that. That's okay. Alright, so now...
No.
Is yours a plus?
Stefan's is a plus, but mine isn't. Yeah,
Mine is
I did change some of them, then I copied.
Wait, what's supposed to be a plus?
This is going to be a plus.
The negative
plus
x.
x.
Yeah, interesting. I did change it, but then I copied off the wrong one. There we go.
Yeah, that's the original. Oh, Stefan has the original one.
Do you have the original?
I already wrote it.
That's okay. Keep it. I'll just make sure I fix it for the next time around, okay?
I guess the one.
Yeah. Okay. All right. I knew I'd fixed it, but then I copied off the wrong one. It's okay. It's all good. So anyway, now it's going to work. So if I look at this, the first question talks about vertical asymptotes and poles. Okay. So A. So first of all, let's take a look at the vertical asymptotes. Okay, we can't divide by 0, can we? Cannot divide by 0. However, we could get rid of the x plus 3's, right? If we can get rid of the x plus 3's, then that is not a vertical asymptote. That's going to be a hole. But the x minus 2 we can't get rid of. We cannot get rid of this no matter what. So where the x minus 2 occurs, we'd have a vertical asymptote at x equals 2, okay? If 2 are here, 2 minus 2 is 0, you can't get rid of it. So that is my vertical asymptote at x equals 2. That x value will make me divide by 0. I cannot remove it, so it's a vertical asymptote. The hole is where it's removable. So at x plus 3, since it's removable, I can cancel out. It's a hole. So at x equals negative 3, I have my hole. Okay.
It doesn't work, Davies.
What?
We grabbed it in the calculator. The whole set positive 3.
Did you change this?
I don't think I've changed.
That's okay, yeah. That's my fault for giving you the wrong one, okay? So now, my hole has a coordinate. So what I do to find the y value, so my hole's at negative 3 something, right? You can't plug negative 3 in. You can't. Boys, remember what I said rudely? Okay.
Yes.
You cannot plug in negative 3, but if you remove it, you can. So once you remove it, if you cancel it out, you're left with a 3x plus 1 over an x plus 3. X minus 2, darn it. 3x plus 1 over an x minus 2. Once I get rid of the x plus 3, I can put this back in without dividing by 0. So when I get rid of the problem, what's left over is the 3x plus 1 over x minus 2. I can put in my negative 3 now. So I can go, okay, I can go ahead and 3 times a negative 3 plus 1 over a negative 3 minus 2. I can actually put the negative 3 in, so I get a negative 9 plus 1 makes a negative 8 over a negative 5, which is a 1.5 6, or 1 3/5. That's the coordinate of my hole. I'll circle that. There's my vertical asymptote, okay? Now the zeros. The zeros are when the top is 0. 0 on the top is 0. Well, if I take a look at what I have on the top, I can't use this one because this one canceled out. But I can use the 3x plus 1. So when the top is 0, it's 0. So I'm just going to take my 3x plus 1 and set it equal to 0. And I'll get my 0, okay? Yeah. Minus 1, I get 3x equals negative 1. Divide by 3, I get x equals negative 1/3. So that's a 0, which is the same thing as an x-intercept, okay? It's my 0, which is also an x-intercept, okay? Horizontal asymptote. Okay, well, the horizontal asymptote is when we let x go to infinity, okay? When x goes to infinity. So I'm going to go back up to the original problem, and I'm going to put in infinity. So I'm going to go, okay, 3 times infinity squared plus 10 times infinity plus 3 over infinity squared plus infinity minus 6. And we're going to think about infinity as being so big that it just gobbles up everything a little, right? I mean, infinity plus 3 is just infinity, right? And 10 times infinity is just infinity. But when I square infinity, it's so much bigger than this infinity, just gobbles it up, okay? Now the same thing occurs here. If you take infinity, subtract 6, it's still infinity. If you square infinity plus infinity, it just gobbles up. So what you really wind up with is infinity squared over infinity. So if you cancel those, you're left at 3. So my horizontal asymptote is y equals 3, okay?
So if you have a squared infinity, it eats the not squared infinity?
Those just cancel each other out, right? Does that make sense? Now, domain. Let's go back to this for domain, okay? Okay, if I go back up here for domain, okay, one of the things we know is x cannot equal negative 3 and x cannot equal 2. It can equal everything else, but it cannot equal negative 3 and it cannot equal 2. So domain is x equals all real numbers except x cannot equal negative 3 and x cannot equal 2. There's my domain. Okay, now I'm going to graph it, all right? How am I doing? So far, so good? So let me take all of this information I have and let me put it on a graph, all right? So I've got a bit of a mess here, but let me get my graph out, and I'll come back to that, all right? So I'm going to go like this, and of course you can look at it on the calculator too, but you don't need the calculator, believe it or not. So right off the bat, let's put in my vertical asymptote at 2, okay? So at 1, 2, I'm going to put in my vertical asymptote. All right, there's my vertical asymptote. My horizontal asymptote is y equals 3. Let's put that one in. Okay, I've got a hole at negative 3, 1.6. 1, 2, 3. Negative 1.6 is about there. So put a little hole. See, there's my little open hole. I've got a x-intercept or a 0 at negative 1/3. That's about there. And then I really have enough to graph. I really have enough of this information to graph it to get a pretty good idea. And of course, you guys are of course going to look at it on your calculator. Of course you are. But if you look at your calculator, what I have should be exactly what you have. Marie, do you have it graphed already?
Yep.
Okay, let's just look at what Marie put in. Actually, Marie it put in the asymptote, didn't it? They don't always show the asymptote. Kind of depends on the window. And here's the equation. Remember, if you're going to put it in the calculator, one thing Marie has that makes it work is the parentheses and the parentheses, because you need the entire top divided by the entire bottom. If you forget the parentheses, you won't get the right graph, will you? Okay, because it'll just divide the last two things. Okay, everybody good on that? Thumbs up. I want to see. Okay, thumbs up. Can you do this tomorrow? We're getting better at this. Remember when we first started doing this? You guys are like, this is weird. But you're getting better. We have practiced these problems, I think, just about every day, haven't we?
When did we start this?
About 2 weeks ago. Yeah, about 2 weeks. So we've been doing this for a while, haven't we? Okay. All right, let's take a look at question number 2, okay? Okay, so question number 2 is A is x to the 4th plus 2x squared minus 8 is less than or equal to 0, okay? Now, on a number line, we're going to do it on a number line. The reason we're going to do it on a number line is there's no y variable, right? There's no y, so it's not going to be a graph. It's just x's, so the whole answer is going to be, it's going to be on a number line, okay? So let's go ahead and draw a number line. But we need our border points, right? So this one does factor. In fact, I'm going to look for your factoring. So let's take my equation and let's factor it first. Okay, parentheses, 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 and let's set it equal to 0 when we get our border points.
Davies.
Am I off paper? Thanks, Marie. X squared, because that makes x to the 4th. And I'm going to use a positive 4, negative 2. Positive 4, negative 2, okay? So then if I set them equal to 0, I've got an x squared plus 4 equals 0. I've got an x squared minus 2 equals 0. I just want to find the border points, find out where it's equal to 0. Bring over the 4, I get x squared equals negative 4. And this one I'm going to have a problem with because I'm going to take the square root of it. We get plus or minus square root of negative 4, which is an imaginary number, but we are on a number line, so we're not going to graph this because you don't graph imaginary numbers. So we're going to throw that one away. We don't graph that one at all. Okay? You can't graph imaginary numbers. Okay? You can't. Here, though, we'll bring over the 2. We'll get a positive 2. We'll take the square root of it. Now, it has to be plus or minus because you have to have 2 answers. Square root of 2. Now, square root of 2, it's about 1.41. Okay? So all we need to do is go to our graph and put in our negative square root of 2 and our positive square root of 2, okay? Solid dots. Here, let me use a different color. Solid dots. You guys okay with solid dots? Now, we're either going to shade this region, we're going to shade this region, or this region. How do we know which ones to shade? Yeah, the calculus is a great idea. That's right, Alondra. So if we go and we go to y equals and clear that out, I'm just going to graph it. X to the 4th plus 2x squared minus 8. If I graph this, I might have to change my window a little bit. Don't really need to change it, but I will a little bit. It'll work, but I'll change my window to normal window. Zoom 6. Let me go ahead, normal window, okay. Now, I already know what the answer is because I can interpret it less than 0, so it's this region here. But at the same time, let's just do it the other way. Let's test points. So if this is a 1.4, if this is a negative 1.4, let's put a number in here. What number would you like to test over here?
5.
Negative 5? Negative 5 works. Why not? So I'll go trace, negative 5. So I get a positive number, okay? I get a 667. That's positive, right? Okay, give me a number in here to test. 0 sounds like an easy one, doesn't it? I get a negative 8, so I get a negative number, okay? Okay, give me a number over here to test. 3, why not? And I get a positive number. So, we want it where it's less than 0. Where am I going to shade?
In between.
We're in the middle, because that's where negative numbers are less than 0. So I just shade in the middle, okay? Nice. Now, if I had to do the answer also in interval notation, right? I'm going to do something like this. Bracket, right? You guys agree with bracket? Negative square root of 2, comma, square root of 2, bracket. Bracket because it's solid dots, right? Thumbs up? Okay, not bad. Alright, you ready for number 2B? 2B? 2B or not 2B, huh? That is the question. I know, funny guy, huh? Sorry. Alright, 2B. We've got a 2x plus 7 over an x squared plus 3x minus 18 greater than or equal to 0. Okay, so now let's find all of our border points. So, first of all, I'm going to factor the denominator. X plus 6, x minus 3. Okay, think about that. They'll multiply to make a negative 18, and they'll add to make a positive 3, right? So my border points come from this. 2x plus 7 equals 0. X plus 6 cannot equal 0. And x minus 3 cannot equal 0, okay? Now I put the cannot because if they are, then we divide by 0, and that's bad. But it still makes them a border point because it can't be that, right? Okay, bring over the 7. Divide by 2, right? And I get x equals negative 3.5. Bring over the 6, so x cannot equal negative 6. Bring over 3, and x cannot equal 3. Okay, getting there. Number line. Got my board points. Let's put them down. Negative 6, negative 3.5, and 3. Okay? I know for sure I'm going to do a solid dot here, but I'm going to do an open dot here and an open dot here. It has to be open dot here because if it did equal 3, you would divide by 0, and that'd make Cookie Monster sad.
How do you get negative 3.5?
Okay, 7 divided by 2.
Oh.
Got it? Yeah. So, good question. I'll take any question, right? Now, the question is, where are we going to shade? Well, let's graph it, okay? And let's graph this one. See my parentheses? Parentheses, right? Don't forget your parentheses, so I'm going to put in my calculator, clear. I'm going to go a parentheses of 2x plus 7 divided by parentheses and x squared plus 3x, subtract 18, and I'm going to graph it. Okay? Okay, kind of a weird looking graph, right? But all we care about is whether it's positive or negative, right? So we want positive values, right? We do. So let's go ahead. Go to trace. Give me a number over here. Negative what? We'll put that's over here. Negative 8, okay? Negative 8. It's all good. So I got a negative value, okay? Got a negative value for there. Okay, now let's try negative. What do you want to do here? Negative what?
5.
Negative 5 will work. I get a positive value, okay? Give me a value in here. 0. Priority, remember when you guys did your little chart? Did you see I'm doing the same thing, aren't I, as the little chart, right? Remember when you guys did your little chart? I really am doing your little chart, aren't I? Yeah. And that's a negative value. And then give me a value over here. 5. And I get a positive value. So, if I look at my question, I'm looking for where it's greater than 0 or equal to 0. And that's going to be where it's positive. So I want to shade here, right? And here. Okay? How am I doing? Good? Great question. If it equaled negative 6, you're going to divide by 0. So don't let it equal negative 6. So in the denominator, the bottom, think about the bottom. In the bottom you can't divide by 0, right? Can't be 3 either, right? They are border points, but you can't let them equal those values. In fact, if you go back and look at the graph, right? If you go back and look at the graph, that's not the graph I wanted. Hold on. Oh, here's the graph I wanted. If you look at the graph, you find asymptotes there anyway, don't you? You do. You find an asymptote there and an asymptote there. So they don't equal those values anyway, right? Okay, interval notation. Let's go parentheses, negative 6, comma, negative 3.5, bracket, union, same thing as or, parentheses, 3, comma, infinity, parentheses. Because you can't get to infinity, right? How's that? Thumbs up? I see one thumb up. There's 2. Yeah, you can put an or. Yeah, I'm just trying to slip in some math. You know how I am. I casually slide it in there, so if you see the symbol, you go, oh, that means or. See what I do? I'm very tricky, aren't I? Elijah, I throw in more math every day that I just trick you into seeing, okay? Yep. Okay, ready? 3. Turn the page. All right, number 3. Okay.
13 days.
No, it's not. 3. F of x equals 12e to the negative 0.5x. Okay? Yep. Totally right. You're way ahead of me. I like that. Okay, now, so all I need is this. Okay, all I need I need the shape. I need 3 things on this graph. You don't have to use a calculator. I need 3 things. I need to make sure that it starts at 12. So if I go, 10, 20, 30, 30. It absolutely must, I'm going to look for this. It absolutely has to start at 12. Has to. Has to, okay? It also, because of the negative, it's decay. So it has to go down. That's the third thing. It's got a curve, right? Because of the negative right here, because of this negative right here, I'm going to highlight it. Because of this negative, it's decay, right? And we'll check it. We'll check it on the calculator, okay? But I can do this without a calculator. Okay, then the second thing, or the third thing, is that it's going to swoop down but never touch the x-axis, right? We talked about that. So the graph is going to look like this. And that's what I need. Now, if you say, gosh, I don't know what he's talking about. He just talks in riddles, right? If you feel like that some days, all I do is talk in riddles. You could always say, okay, I'm just going to graph this, Mr. Davies, e to the, right, negative 0.5x. Okay. Now, let me change the window so I can get a little bit better window. Hey, looks like the same thing I just drew, doesn't it? What do you know? Okay. Isn't that easy?
Wait, so what is E?
E is that special number. We're going to have to find that next, okay? But let's wait on that, okay? Domain. What's the domain of this function? Yes. All real numbers. Exactly, yes. What's the range?
Anything greater than 0?
Yes, yes, yes. Y is greater than 0. Perfect. You just use words. I use symbols. We're saying the same thing, Elijah. Anything greater than 0, okay? Or Y is greater than 0, okay? But not equal, because it doesn't touch the x-axis, does it? It's like half of a half. Half of a half of a half. Half of a 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 half. Will you ever get to 0? No. You'd have to get to infinity to get to 0, but that can't happen, right? Okay, now what is the number E? Define the number E. Define E. Okay, it's this easy. Don't miss it. Write it like this. L-I-M. N approaches infinity, okay? Write it like that, okay? Start right there, okay? That little L-I-M, which stands for a limit. Limit means get closer and closer. The whole idea of a limit, when you take calculus, is the idea is this. If you want to get somewhere that you can't go to, you're going to get as close to it as you can. So we're going to approach infinity. We can't get there, so we approach it. You cannot get to infinity. But we're going to say, in theory, let's approach infinity. Of 1 plus 1 over n to the n power. So as the values of n get bigger and bigger and bigger and bigger, it gets closer and closer to the number e. That's what I want to see in your test. If I see anything else, I'm going to mark it wrong, and I'm going to feel bad for you because it was that easy. Okay? And you'll do limits in calculus. You will. That's why it's good if I show it to you first, okay? Okay, turn the page. Everybody good?
Wait, there's one more.
Okay, good.
5.
Well, yeah. Well, actually, there's more. There's 5, 6, and 7, okay? Okay, gone.
Wait,
Let's do number 5. Okay, and does everybody have a calculator?
Yeah.
Okay, let's do this together, because what happens every year, what happens every year is kids write it down correctly. They get it wrong because they don't put it in the calculator right. So if we all do it together to make sure we get the same answer, then things are going to be great. Okay, so first of all, in 5, Landon's got $1,000, okay, for 8 years, okay, and he's got 3 different options. Bank A, we're going to do 3% compounded annually, okay? So, we're going to go like this. A of 8, the amount after 8 years, right, is equal to, am I going too fast? You need to catch up? Okay, tell me slow down. So, I'm going to go 1,000 times 1 plus 0.03 to the 8th power. That's all. That's all. Let's see what we get. Let's see if everybody gets the same answer, right? I want everybody to try it so that you don't get it wrong tomorrow. 1 plus 0.03 to the power of 8. And I get 1,000 $266.77. Okay, thumbs up if you got that answer. Everybody get that answer on the calculator? If you didn't get that answer on the calculator, then got to make sure you put it in the calculator right. Okay, that's why we got to practice, right? No E yet. Okay, everybody try it. Everybody try it, okay? Thumbs up if you got that answer. Okay. Okay.
Oh my god, no. I put 0.3 instead of 0.02. Oh.
Okay.
Yes, I got it. Hold on. 0.03, that's what it is.
Okay, it's super easy, but what happens oftentimes you put it in the calculator wrong and you get the wrong answer. There you go. That's why I want to practice this, right, Alondra? That's good. Okay. Okay, you ready to do the next one?
Yeah.
Okay, B. Okay, bank B. Yeah, it's not hard, but we got to put it in right. Okay, bank B is 2.7%, 2.75%, and as a decimal, that's the same as 0.0275. And we're going to do it monthly. So if it's monthly, N is 12. 12 months in a year. We're going to compound it 12 times a year. So A of 8 equals, we'll take our 1,000, 1 plus 0.0275 over 12 to the 12 times 8. The kids came at lunch and they actually had one of these problems on the test, on that darn SBAC test. I'm like, oh, hallelujah, we just taught that this week. Lucky you, huh? Yeah. They're like, I could do that one. I go, yeah, you can. But I'm thinking, what about the poor kids that didn't have pre-calc? Right? I mean, is it really a high school test or is it really a advanced high school test? That's a good question, isn't it? Right, Alondra? Right?
I didn't really have anything algebra to like. I mean, it did, but like, it was like just it was different. It wasn't really algebra.
Yeah, it's more of a pre-calc, huh?
Yes, it is.
Okay, so let's go 1,000 parentheses 1 plus 0.0275 divided by 12 to the power of, now I'm just going to make this power 96. It's easy for me. If you don't, then you better make sure you do parentheses, okay? Does that make sense?
Yeah.
I'm going to do it 96 so I don't make it a mistake, all right? But you got to make sure that 12 and the 8 are in the exponent, right? They both have to be in the exponent. That's why I need to use parentheses, okay? Okay, here's my answer. So I got $1,245.76, okay? Everybody give it a try. Everybody, give it a try. I want to make sure everybody gets the right answer, okay?
That's what I got.
Okay. Now, if you don't get the right answer, then make sure you can, because it's really not a hard problem. We just have to type in the calculator correctly, okay? Okay. Analia, right? Marie?
Yeah.
Sarah, you got it? Lane, you're good? Wyatt? Brooke? Okay. Octavio, did you get it? Okay. Lauren? Ashley? You got it yet? Okay, guys?
Yep.
Okay, Carmen, Alondra, you got it?
I got it.
Gerardo, did you get it? Okay, let's move on to the next one. Now, one thing for sure, listen carefully. Your numbers should all be about the same. Does that make sense? Because you're investing $1,000. If all of a sudden you get one investment, it's like umpteen $1 million, that would be really good, but probably isn't going to happen, right? If you give a bank $1,000 and you came back a year later and they gave you $1 million, something's not right. So if your numbers aren't about the same, you know you've made a mistake, okay? Okay, the next one. Compound it continuously. Bank C. So bank C is going to compound 2.5% continuously, okay? So we use A of 8 equals. We're going to use the PERT formula. We take our 1,000 E to the 0.025 times 8. Okay? Guys, what's up? Okay, come on here. I'm recording. Come on. So let's try that, okay? Let's see if we get 1,000 second